Okay, this lesson is on inverse trig functions, and before we get specifically into this, I want you to remember that anytime we are talking about inverses, that it has something to do with switching x and y. And we'll be coming back to inverses and the concept of inverses when we do other functions as well. But right now, since we're focusing on trig, those are the ones we're going to focus on. And so this first thing, this example that I have written right here, you have the sine of pi over 4 is the square root of 2 over 2. Those are the kinds of questions we've been answering from our unit circle. When I say the inverse of sine, the x part and the y part switch, the input and the output switch. So you'll notice the square root of 2 over 2 is here, and the answer, the angle, is here. However, when you are answering the inverse, you can have more than one answer because this is asking the question, what angle has a sine of square root 2 over 2? And that answer is pi over 4, but it's also 3 pi over 4 and many others if I kept going around the circle. And so there's infinitely many answers in this situation for the sine inverse of square root 2 over 2. So a lot of times we'll say, give me the first one you come to, or give me the ones that are on the unit circle. But again, the concept is that the input and the output are switched. So if they ask you for the inverse, they're giving you the value from the point and they're asking you for the angle. Okay, something else, in previous classes you have probably dealt with this inverse, or even when we were solving the trig, the triangles, we used sine inverse, cosine inverse, and tangent inverse. Those are also represented by arc sine, arc cosine, and arc tangent. They mean the exact same thing. So if you see arc sine, that means the exact same thing as sine inverse. Arc cosine means the exact same thing as cosine inverse. These are just sometimes used in upper level math, so don't think of them any differently. This is where you're going to want to look at your unit circle. And we're going to answer these examples. So the first one, I have the arc sine of -1/2. So I'm looking on my unit circle for the place where the sine is -1/2. The y value is -1/2. The question is, what is that angle, or what are those angles? And we'll just answer right now with the ones that are visible on the unit circle. So we should have at least 2 here. And hopefully you found 7 pi over 6 has a sine of -1/2, and 11 pi over 6 has a sine of -1/2. But those are, again, are just 2 of the possible answers. Okay, example 2. Arc cosine square root 2 over 2. So I'm looking for the angle that has a cosine of square root 2 over 2. Okay, the angles that have a cosine of square root 2 over 2 are pi over 4 and 7 pi over 4. Okay, this would be a good time to pause your video and check and see if you can answer the next 3. Okay, so our third one, the tangent inverse of 1 means we're looking for an angle with a tangent of 1, and that ends up to be pi over 4 and 5 pi over 4. Number 4, arc tangent of 0 means we're looking for the angle with a tangent of 0. And again, if you're calculating your tangents on your unit circle, that's going to happen 3 places. It's going to happen at 0, at pi, and at 2 pi. And then number 5, sine inverse of square root 3 over 2. We're looking for the points that have a y value of square root 3 over 2. The angles that give us that are pi over 3 and 2 pi over 3. Now, for the last example of this kind, I have cosine inverse of 2. So think about your unit circle for a second. Where would you have a cosine of 2? Okay, I put this one in here because they will try to trip you up sometimes. If you think about your unit circle, the biggest cosine that you have on the unit circle is 1 because that point is farthest to the right at 0, pi, I mean not pi, but 0 and 2 pi, the x value is 1. That's the farthest point you have to the right. So you're not going to have an angle that has an x value of 2 if the circle is not going that far. And so the answer to this would be not possible. Okay, now I want to talk about the relationship between some of the inverses that you do know. For example, you know that x squared and the square root of x are inverses. What happens if I say the square root of x squared? They cancel. The square root and the square cancel each other out, and you get x. Okay? What happens if I say the natural log of e to the x? Those are inverses of each other, the natural log of x and e to the x. So they cancel each other out, and again you get x. So if you notice, every time that you have two functions that are inverses of each other, they should cancel to x. Okay, the same thing is going to happen to trig. So I'm going to write this in general because, again, we're going to come back to some other functions and this is going to come up again. So in general, if you take a function and do a composition with its inverse, you put one inside the other, that answer should be x. Okay, so if you do a composition, f of g of x, with a function and its inverse, that should be x. Okay, so since we're talking about that relationship where a function and its inverse cancel each other out, you'll notice I have a couple of examples of that with the trig versions. So if I do the tangent and the arctangent, those are inverses of each other, so those cancel out, and my answer is just what's over here. So my answer in that case would be -5. Another example is this number 8. I have arcsine and sine. Those are inverses of each other. They cancel out. My answer would be 5 pi over 3. Now, 9 and 10 look kind of like 7 and 8, but if you'll notice, they're not exact. 9 is cosine and arcsine, so those are different. 10 is sine and arctangent. Those are different. Those can't just cancel out. That means you need to work from the inside out when they're different. So in other words, I'm going to bring down the cosine, but I'm answering the question, what is the arcsine of 1/2, just like I did in the first 6 examples. So what is the arcsine of 1/2, and just give me one angle, the first one you come to in that case. So the first angle in the unit circle that you come to with a sine of 1/2 is pi over 6. And then that changes your question. Your question is now, what is the cosine of pi over 6? And that goes back to what we were doing the other day with the unit circle. What is the cosine, or the x value, at the angle pi over 6? And hopefully you get square root 3 over 2. So then let's look at 10. Again, work your way from the inside out. So I'm going to bring down the sine, and then I'm going to answer the inside. So what is the angle with a tangent of 1? And we did that one, I believe. The first one you come to on the unit circle, we're going to use it. Hopefully you get pi over 4. Then the question is, what is the sine of pi over 4? And you're just looking for that point again. You're looking for the y value on the point at pi over 4. And that is square root 2 over 2. Okay, the last thing that we're going to talk about with these inverses are their graphs. And the thing is, to be a function, it must pass the vertical line test. And the mathematicians who were working on this stuff, they needed these things to be functions. And so we're going to talk about what the graph is for the arcsine, the arccosine, the arctangent, and how it was made into a function. Okay, so the first one we're going to talk about is arcsine of x. And as I mentioned, with inverses, you switch x's and y's. So if you think for a minute about the sine graph, I'm just going to sketch it over here, and it goes forever, okay, doing the wave. If I switch my x's and y's, what's going to happen is it's going to be, the x-axis is going to be now what the y-axis, labeled the way the y-axis is labeled here. Basically, we're switching the x and y-axis. So what would happen is this graph would look like this. Okay, it would continue up forever. Now, is that a function? No, it doesn't pass the vertical line test. So, what the math gods, as I call them, did was they decided to look at a particular part of the graph, and they continued it down here. And I'll do a very nice and labeled one in just a minute. Just be listening. And they said, well, we're just going to use this part of the graph, and that is going to be our part that we talk about when we say arcsine. We're going to ask you the values that fall in this range, and that way it passes the vertical line test and it's a function. So it's like they're just chopping it off and only using part of it so that it does pass the vertical line test. The part that they use, and this is important to remember, goes from negative pi over 2 to pi over 2. This would be part of the domain on sine. It's part of the range on arcsine. Okay, so what I need you to know is that the domain of the sine graph becomes the range of the arcsine graph, and the range of the sine graph becomes the domain of the arcsine graph. So think about how we labeled the x and y axis. On the sine graph, we labeled the y axis from -1 to 1. So on this graph, I'm going to label the x axis from -1 to 1. They have limited me to, on this graph, having a range of negative pi over 2 to pi over 2. So I'm going to have negative pi over 2 be my low point, pi over 2 be my high point. And so this is pi over 4 and negative pi over 4. Although those aren't necessarily what you need, you definitely need to know the -1, 1 and the negative pi over 2 and pi over 2. Now if you think about the sine graph, sine is 0, 0. The sine at pi over 2 is 1. The sine at negative pi over 2 is -1. So these 3 points are going to get you your graph turned sideways. A sine graph normally humps uphill, so sideways it would look like this. Okay, and then the other side would be like this. But we are stopping it at those 2 points again because the way they say it's a function. The other thing is, you also know they're just using this part of the graph when it's a capital A. If it's a little a, they're talking about the whole thing going on forever. But the capital A says, hey, we're limiting it to go from negative pi over 2 to pi over 2. Okay, now that we get the concept of turning sideways, we're going to do arctangent. And the reason I'm doing arctangent instead of arccosine next is because it's related to the sine and what they chose as the domain to select on tangent, which would be the range on arctangent. It is also from negative pi over 2 to pi over 2, but notice I'm using the parentheses because you cannot include those. That is where your tangent graph has vertical asymptotes. And so I'm going to label my y-axis from negative pi over 2 to pi over 2, just like I did with the arcsine. That's our restriction there. But again, on tangent, you have a vertical asymptote at pi over 2. So on arctangent, it's a horizontal asymptote because x's and y's switch. and you will also have one at negative pi over 2. Now you can label your pi over 4 and your negative pi over 4 and negative 1 and 1. And then if you remember, the tangent at 0 is 0, the tangent at pi over 4 is 1, the tangent at negative pi over 4 is negative 1. So you have those 3 points, and then that will lead you to the shape of your tangent graph, and it should look just like that tangent graph turned sideways. And so they're just using one period of the tangent graph. It's a different period than we were looking at in our previous video, but if you just use one, turn it sideways, it does pass the vertical line test. And so this is the shape I need you to know. Okay, I saved arc cosine for last because they had to choose a different section of the domain, because negative pi over 2 to pi over 2 would still not pass the vertical line test. And so we are using from 0 to pi, including 0 and pi, so square brackets there. And so my y-axis gets labeled the same way, negative 1, 0, 1, just like, my x-axis gets labeled just like my y-axis did before. And all three of them, again, are labeled this way on the x-axis. This one, since we're going to pi from 0, pi is now a y value, and I have from 0 to pi, pi over 2 being the middle. The cosine graph, normally you have the cosine of 0 is 1, so if I plot that, we're here. The cosine of pi over 2 is 0, and the cosine of pi is negative 1. And so those 3 points can get you that general shape. Just remember that the cosine graph curves, so we're curving these a little bit. This is your arc cosine graph with capital A, because that domain is limited so that it passes the vertical line test. Again, I really just need you to know all three shapes and how to create them and label them correctly. There won't be any shifts or translations, amplitude changes, period changes with these. Everything I need you to know is on those three graphs I just showed you.